Hi everyone, welcome to my DE3. In this DE3, I'll be doing the case study for the maximizing revenue functions. So this is the problem that I'll be working on. A local theater sells tickets for their movie showings. They currently charge $12 per ticket and average 500 visitors per show. A survey suggests that for every $0.5 increase in the ticket price, the theater will lose 20 visitors per show. Yes. So here is how I would solve it, present it on the board as like how I said like I would improve myself from last week, which is to present as much information as I can on the board so that it is easier and more professional for me to present. So in order to find out the maximum revenue, there are two things I'll have to calculate, which is the revenue functions and the marginal revenue. So the revenue functions formula is R parentheses x equals price x quantity, while the marginal revenue equals r x equals 0, because the marginal revenue is like need to set to 0 in order to calculate like maximum or minimum. It's like the base for calculating the maximum and minimum. So firstly, I will calculate the revenue function mainly, which equals rx equals px multiplied by qx, which is like x is like the number of like $0.5 increases. Next, I'll expand using the FOIL formula, which is like the standard like way of like multiplying two binomials. And after like doing that, I get r parentheses x equals minus 10 multiplied by 2 plus 10x plus 6,000, which is the 6,000 is like the normal revenue that people got, which was like $12 and 500 tickets. Multiplied, we get like the revenue of $6,000. Next is the marginal revenue, which as I calculated would be marginal revenue. The standard would be Rx equals dxd in parentheses minus 10x2 plus 10x plus 6,000. After this, I can set the r to like 0 because I'm making the base for it, and it will become minus 20 x plus 10 equals 0. So 10 equals 20x. So in this case, it means that x is like 10 over 20 as a fraction, which is like 1/2 and is 0.5. So I've calculated the amount of like increases, like the value of the increases, and confirmed it. Now I'll have to find the optimal price and how much revenue I would get after like the optimal price. So the optimal price is P as like I chose like in the last few weeks the profit functions, which would be P dot in parentheses 0.5 equals 12 plus 0.5 multiplied by 0.5. So this means that I have the amount of 0.5, which effectively means it's 0.25. So P 0.5 equals 12 plus 0.25, and since there's still like the 0.5 from earlier, so it's so it's P 0.5 in parentheses equals 12.75. So that's the optimal price in order to get the maximum revenue. And to do the maximum revenue, I'll calculate revenue 0.5 as minus 10 in parentheses 0.5 to multiply 0.5 by 2, which is 1, plus 10 multiplied by 0.5, which is 5, and 6,000, which is the original revenue. So next I'll have R 0.5 equals minus 10 in parentheses dot 25x plus 5 plus 6,000. And then after I multiply minus 10 by 0.25, I would get minus 2.5 plus 5 plus 6,000, which equals to 6,007.50, like $6,007.50. Yes, so that is my answer for this case study. So in this case study, I generally learned about how the revenue functions worked, got a little bit of practice with the revenue functions as well as the marginal revenue, and lastly, I also got like a new formula to work with and like more of a big understanding of math and algebra. So that's all for this video's case study. Thank you for listening and have a nice day. Bye.